So the title of my presentation is Potential of Photographs Digitalization and Thermal Imaging for Plant Studies. So I will report also on experiments that was performed with colleagues from University Novi Sad. It was a drought stress experiment. And so my background is I'm a meteorologist, so most of the research areas that I have are not really connected with plants and with Excel. So I will, in this case, only report on this digitalization and visualization of photographs. So I will first report on this Droughtstressed experiment, also show some results of an analysis of routine webcam pictures, and also say something about Raytracing modeling, which is also used for visualization. So this doesn't work. So it should show here a picture, visible picture. So if you have three channels, intensity in three channels, you should get a visible image. So the usual method is this RGB method. So you need in red, green, and blue. You need some data, and you can get a visible image. And this is the reverse process, is digitalization of a photograph. So you get then three channels, blue, green, red. So here you can see the grayscale. And if you show the pictures, it looks like that. And so first, this Droughtstressed experiment, we had tomato plants in 2-liter pots. And we had different treatments concerning watering. So treatment 1 was well watered. So treatment 2 was a medium water stress. Treatment 3 was a strong water stress. And then we had also extreme water stress. 3 plants which were in the shade were not watered for 1 day. And a student of mine, Sandro Oswald, took some infrared and visible photographs of the plants 4 times per day, so of the 27 tomato plants. And we had a distance between the tomato plants of 40 centimeters, covering an area of 7 square meters. So thermal infrared, the basic principle is related to the energy balance on the leaf, which gets some shortwave and long-wave radiation, which loses some sensible heat. And the important energy flux is this latent heat, which is related to the transpiration of the leaf. When there is some drought stress, the plant closes its stomata, so reduction of transpiration, reduction of evaporative cooling, and increase in leaf temperature. This is a well-known phenomena. Here you can see the thermal infrared camera, so it measures the long-wave emission of an object, and it's automatically converted into a temperature using the Stefan Boltzmann law and assuming an emission coefficient, which was 0.98 for the plants. It was Sandro who looked in literature. It seems that 0.98 is more accurate than 0.95. So here you can see a typical measurement, infrared picture, visible light picture. So he looked at some areas which were in the sun, for the stalk, for the leaves, then in the shade, like here, and stalk in the shade. And he made over a given area an average, and looked also at maxima and minima values. And the usual method is to refer it to the air temperature. So it got the data from this company, Blue, from Novi Sad. Here you can see the temperature. Blue is relative humidity, precipitation, wind speed. And then you refer it and you make the difference, leaf temperature minus air temperature. So it's shown for these 2.5 days. And blue is well watered, red is medium water stress, green strong water stress, and the upper line is very strong stress. This is for leaves in the shade, this is for leaves in the sun. So in general we have a higher leaf temperature than the air temperature. It was for us astonishing, so we were not expecting that, but we looked yesterday in literature. We found also studies reporting on higher leaf temperature than air temperature. So this is now for the stock. You can see the variation is less between the different treatments as we would expect. The temperature is higher because you do not have any evaporative cooling. And you have, of course, higher temperature when the stock is in the sun compared to the stock in the shade. So here you have a table summarizing all the experiments. So this is well-watered, medium water stress, strong water stress, extreme water stress. And as we would expect, you have an increase in temperature when the plant is suffering from drought stress. It's something like between 3 degree difference and yes. So if you compare it with literature, this is a very old paper by Izzo et al. So it's for stressed soybeans, so drought-stressed soybeans. In general, here you can see that the temperature, this is the difference between leaf temperature minus air temperature. The temperature is above 0, the temperature difference. But when you look at well-watered plants, usually it's below 0 degrees. So that was for us we were not expecting this, but as I just mentioned, we found also other values from literature which show much higher leaf temperatures and air temperature. So this is of course connected with the energy balance. Here you have temperature of the leaf, air temperature, net radiation, soil heat flux, water pressure deficit, and using this energy balance, the so-called Cropper water stress index was developed with an upper baseline, so it shows the maximum possible difference between leaf temperature and air temperature, and the lower baseline, which is for well-watered plants. So we will go a little bit more deeply into that, also looking at the energy balance. Second point was how can we use visible pictures, and Sandro made a Python software which digitalized, so you can choose pictures, you choose the color or the ratio you want to use, what would you like to analyze, and then you get a result. And so here you can detect, for instance, the flowering of the tomato plant using this algorithm, but this wouldn't bring many more information for our study. So we choose another approach. So here you have the same plant on the 28th of May and the 29th of May. This is the extreme water treatment, so you can nicely see the wilting of the plant. And what Sandro did, he first detected the green color, so you filter the green color out, and then you use the so-called plant CV algorithm to get the shape of the plant. And you see here we can get much more information concerning which is related to the wilting. You see, for instance, the width is much smaller for the wilting plant. The error is much smaller, only 894 pixels compared to 1097 pixels. So this, I think, is an approach which would be worth to continue. So another question was also concerning the accuracy of the thermal infrared camera. We need, I think, also to make a good calibration to see whether this difference between thermal infrared camera and the measured air temperature is correct, or whether we have any systematic error. So second point I would like to make is we make an analysis of webcam images. So I don't know, this should be a animation, but I have it also in animated GIF. So you have apricot trees in the Wachau, so it's near the Danube, where you have routine webcam measurements of the development of the physiological state of the apricot trees. And what you can see is that the illumination is changing drastically. And this is also a well-known problem using this kind of routine webcam images. So we did some tests. So of course you always have to define your threshold when you make a digitalization. This is a simple grayscale digitalization. So when you change the threshold, of course you have other errors which are white or not. But here we see, for instance, we have a problem with the sky, problem with this road, problem with the background. Here is a castle. The sky, you can easily remove it, but we still have this problem with the background. It's the same with another picture. It's 3 hours later, illumination is a little bit different. So we first see that the threshold, which is ideal, is a little bit lower. It's 130 instead of 150. But still you have the same problem with the background, which is white, compared to these flowers, which are white. We would like to detect, of course, the error of the flowers. So I then tried this algorithm by Sonnentag et al. So it's a kind of homogenization to remove these changes in luminance, and we get this kind of picture. Actually, should also be a video, but it doesn't work. So you can also see that here we have still the problem with the road behind. What we can nicely see is things surrounding the flowers, but it's not what we would like to get. So I think here we will have more to go into the shape, use other kind of analysis, this plant CV software, to get first the shape and then to get the white error. So last point I would like to make, it's something I like very much, is ray tracing modeling. And what is the potential of ray tracing modeling? Ray tracing modeling is when you make modeling from the point of view of the observer. So this is only modeling. You get the digital elevation map, you get field of albedo field. Of course, you do calculation in the three in red, green, and blue, and then you get this kind of image. So this is for Vienna, for instance. We have for all Vienna, we have a 50 centimeter digital elevation map. And you can also do it for trees, like here. So what is nice, you have the shape, which of course changes the illumination. We could also connect this with an energy balance model to get really in the small scale the energy balance. Yes, the only thing you need is, only thing, it's not so easy to get 50 centimeter digital elevation map. You need the reflectant radiance if you want to do some visible images like that. And this is embedded in a radiative transfer model, which takes also atmospheric effects into account. Like here, for instance, you have some cloudiness, broken cloudiness. So here you have some sunshine, here is some shade, here you have a small cloud. And this could be used for small-scale energy balance modeling to get a better retrieval of remote sensing data, because when you look at, for instance, forests, you have topography, you have the shape of the trees, which make a very inhomogeneous reflectance field. And this kind of model could be used to remove these effects of the geometry. This is, for instance, a near-infrared picture of Rosalia. You can see you have also topography. Some of the plots are oriented towards east, other towards west. You have also different structure of the forest part, and so this would be a possibility. So that's it. Thank you.